Thank you so much for joining us, and thank you to everyone in our audience for joining Blockchain Fundamentals with Anne Malavet. Anne Malavet has her master's in computer science from New York University and Bachelor of Science from Stern School of Business. She teaches big data at NYU and is teaching a new blockchain and cryptocurrency class starting this fall, 2022. She's been working as a software engineer specializing in data storage and mobile development. And as a hobby, she creates animated GIFs that have over 1 billion views on Giphy. With that, over to you, Anne.
So blockchain fundamentals, and this talk is beginning from when blockchain initially was born. And so the first blockchain was actually created by a mysterious person named Satoshi Nakamoto. And so no one is actually even really sure who this person is. So he published a white paper that was the idea for actually for Bitcoin. It didn't have the word blockchain in it, but blockchain is one of the fundamental resources that like enables Bitcoin to happen. And so this was the first idea for a blockchain, even though there's many blockchains now. Skip this. And I'm going to try to share my screen again. Let's see here. Okay, so I gave a brief introduction as far as like this, that was the first idea for a blockchain, even though it wasn't ever mentioned in the white paper. Blockchain itself, the first time it was used was to enable the use of Bitcoin. Since then, there's been other uses, but that's like the very initial use of blockchain. So I've organized some ideas for blockchain fundamentals. First is blocks, then followed by blockchain network, then transactions on that blockchain, followed by mining, smart contracts, risks of blockchain development and cryptocurrency, and all of the other products of blockchain, some development ideas, and then also a little bit about cryptocurrency exchanges. So let's talk about blocks. So one of the core ideas of blockchain is that there are blocks. So I'm going to actually make a new. Thank you also for bearing with me because I don't have traditional slides. I was going to try to just sort of write out my ideas and so make it a little more interactive. So at the beginning of any blockchain, because there's more than one blockchain, there's always the origin or the genesis block. Okay, so for instance, if I'm making a blockchain, if I'm starting a blockchain today, which I can do, I'm going to have my origin block. And within this origin block, it's going to have some information. So for instance, if we're talking about in the Bitcoin blockchain, the origin block, it's going to have the number of my block. It's going to have a hash, which is basically correlated to the data that's recorded in this. And in a Bitcoin blockchain, all of the transactions that are happening. So we're going to get to later about a little bit about what transactions are happening. Actually, in the Bitcoin blockchain, although it can vary, we're talking specifically about the original. In the Bitcoin blockchain, each block is about 1 megabyte. So there's a lot of constraints on the Bitcoin blockchain that aren't applicable to other blockchains that have been further developed. But this is one of them. So if you're picturing a blockchain, it's limited to this smaller size. Okay, so what else would it have? I have my notes here about what would be in a block. It could have also what's called a target, which would really be when people talk about mining and how difficult it is to find the next block, that's going to be that target. So this is going to be this origin block here. And once this block is filled up, we are going to create another block. And this block is going to be added to the blockchain here. This is number 2. It's going to have a hash. It's going to have a hash. So this is a little bit, I don't want to get too in the weeds here, but one of the reasons why blockchains cannot be broken and why they cannot be changed is because of this hashing. They're all hashed together. And it'll have a new list of transactions here. So another thing to think about with blockchain is it's immutable. What I like to compare it to is if you're familiar with Git or GitHub, you know how anytime you commit something, you can always update it and change it. But like all of those changes are in your repository forever. So the same way in a blockchain, these blocks are going to be there. And so the data can be added onto, but it's never deleted. You're only increasing the length of the blockchain at all times. Okay, so let's go back to what we were talking about. So those are blocks. Those are blocks in a blockchain. Now let's talk about a network. So one of the key things that a blockchain needs is basically the internet. So this is going to be my 2 blocks here in my blockchain here that I'm making. And I am going to make a 1 node within a blockchain network. So I'm going to call this a blockchain network. So that network is the internet. And how are networks connected? They're connected via the internet. So I'll just move this over here. So what does this node here look like? This node is a computer. So if I am a node on this blockchain network, even for Bitcoin, I have software running. I have software running that makes me compliant with all of the rules of this Bitcoin blockchain. So we're talking about Bitcoin blockchain. So this is a computer. This is my computer at home. And I'm a node on the Bitcoin blockchain. And this is my friend's computer. This is computer 2, and this is computer 3. And so these are all connected via the internet. So this is a little bit about like the decentralized idea. And so key to that decentralized idea is that I have these 2 blocks on my blockchain here. And let's see if I can do this, if it's going to let me. I want to paste that. Let's see if it'll let me here. I'm going to paste it again. So we all have the same data that is immutable on all of our computers. We are all nodes in this blockchain network. So what if you want to join the blockchain network? Or this is your computer. So there's software that says computer 4. This is you. What you do is you basically have the software running on your computer and you announce yourself to the other computers on this network. We're all connected already via the internet. What you do then is you download all of this blocks yourself here and you say, hi everyone, I'm a valid node on this blockchain because I also have a valid copy of the blockchain here. And so I'm one of you all, and I can help validate. So this is the decentralized idea. So Eileen, you want to know about hash or hashing. So I am going to talk a little bit about encryption and transactions in a little while. It could hopefully it's sort of like a more complicated concept, but if I could just explain it in a couple of words, it would say, if I'm taking a bit of data and then I'm running an algorithm on it and I have sort of like a long number that can just tie that to that data. I have another example too later. So, okay. But let's get back here. So this is a blockchain network. The network has blocks on it here. So this is a block and it's static now because no transactions are happening on it anymore. We haven't gotten to transaction yet, but this is a blockchain. So everyone there's that resiliency because everyone on this network has the same copy of this blockchain, right? Now we're going to get to transactions. So I sort of glossed over the part where we needed another block because the transactions were happening. But say you want to do a transaction on a blockchain. So for instance, you want to use Bitcoin. What you need to get is a wallet. And so let's see here if I can open my recent files. You want to get a wallet. And so you can create a wallet almost any time here. If you want to go and create a wallet, so a wallet is a little bit of a misnomer. Basically, it's your identity, and your identity keeps track of what the balance is, say, of cryptocurrency on one blockchain. You can have a different wallet for different blockchains. Some wallets support different blockchains. And so I like to think of a blockchain even as like a different database. So if you want to go to a different database, you have to have your different logins. You have different wallets that are identified with that database. So this is my wallet here. So if you go to MetaMask right now, if you go to Coinbase and you get a wallet, there's so many different wallets. You might want to get a secure one because some of them can have security issues. But for instance, a common one is MetaMask. You can add MetaMask as an extension to your browser. You could have it an app in your phone. You could also create your own wallet if you want to have your own identity without using one of these third-party applications. But generally, if you want to interact with a blockchain, you don't have to even know anything about how it works, but you do need a wallet. So this is basics more about encryption. So if you have encryption, you have what everyone calls your public key and your private key. So to have a transaction on a blockchain, you don't have to do anything but have a public key and a private key. And then there's a way for you to sign this so that everyone knows that it's you. And so this is my example here. That's kind of like, it's based on colors, but I think hopefully you can get the idea. So when I have my public key here that I could share with anyone, my private key I don't share with anyone, or they can steal my identity. When I mix my public key with my private key, I get this signature here. Let me try to do this again. I get this signature here. I'm going to try to just copy this. Just give me a sec if I can do this. This is my signature. So I have this color that everyone can identify me by. So it's very hard for someone to guess my private key. If you're going to say that these private key, it could be a color. But anywhere I go publicly, this is going to be easily recognizable as my specific color. This is my signature. Someone can see my public key too, but it's very hard to guess my exact private key. So more easily with colors, but picture numbers where that is hashed together. So again, let's like talking about encryption, and that's like sort of a little bit out of the scope, but it's important to blockchain and transactions. So they're hashed together. I have my signature. And an important thing, again, is that like anyone can look at this and say, without a lot of calculations, they could say, oh, this is Anne's signature. She definitely signed this because this is her signature. I don't have to share my private key. No one else can really make this signature. Very hard to copy and emulate. So this is my signature that I'm going to sign all of my transactions on this blockchain. So this is what my wallet is for. So your wallet can also, you could also use your wallet for logging into what are called Web3 applications. But let me just show you so I'm going to go to CryptoKitties. This is what is called a Web3 application. But if I go here to start Oh no, I don't want to create an account. I want to log in with my MetaMask. I have to reload. Sign in with MetaMask. Open your browser's MetaMask extension. Done. So this is my MetaMask. What is my password? Connect with MetaMask, and I will just say next. Connect to account. I'll say connect. And so this is me logging in. The only identity that I'm using is my wallet here. So this is using blockchain to log me in. I'm not doing any other transactions. It's just really identifying me as the person with this wallet. Okay, so transactions. So if I want to have a transaction, or if I want to buy something, if I want to send someone, and more likely if I want to send someone money. So you could see here, this is, I think my balance, I have like $12. I'm a very high roller. So you can see here, this is my account. You could see here on the Block Explorer. So this is public information here. Just share it here on the chat. If you want to see that, if you want to look at it, this is public information. This is sort of an easy way to do it. And this is Etherscan. So you could see that's a transaction hash. This is the timestamp. That's the wallet that it was from. And this is the wallet that it was to. There's a value of it. It was $6.39. The transaction fee, which is the Ether, and that is 62 cents. So that's important. And that's when we get to mining. The mining is like, that's your transaction fee. So when you think about blockchain, you're thinking about depending on how everyone agrees that we're going to add a new transaction to the blockchain, it's going to cost you money. So how did I get money into my account? I connected it to a bank and then I sent it in. So there's a lot of talk about like anonymous identity. So mine could probably, you know, if it had to be, it could be publicly traced to me. I'm just sending, you know, I just sent myself $6 from another wallet, even just for like the purpose of an example. But it is public information. But it doesn't have to be. And let's talk about mining. So mining, you don't ever have to do any mining if you're going to interact with any blockchain. But when, for instance, you're talking about Bitcoin, why are people doing Bitcoin mining? Because if you find another block, if you solve this problem, then you are going to get the transaction. You're going to get more money yourself. So you're going to make money. And so the more valuable Bitcoin was in the history, the more people are going to want to mine, and the more people that are going to pool their resources together, because the more valuable it is to get Bitcoin. Let me just pull up an example here. So there's a really good example that someone made for educational purposes. His name is Anders Brownsworth. So for instance, this is block 1. And this is the data that I'm including. Like, this is the data that I want on the block. And so what the miners are looking for is they're looking for this nonce. What is a nonce? It's a number used only once. They're looking for a nonce that will satisfy. So if I find it here, that'll satisfy this hash. So it has like 4 zeros in the front. I just did that mining and I found this nonce. So the mining for me, it automatically guessed from 1 or 0 to 49,000 relatively fast. So this is just an example of what it would look like to mine. But if you're picturing why I wouldn't be able to just mine with one computer when you're competing with all of these computers that are like in these, I can't even imagine how big they're taking up as much power as it does in Iceland or whatever. you're not going to be able to find that nonce. And the other example here in blockchain is, so for this data here, and I can mine it and I'll find the nonce for that. And then I have this other blockchain here, I'm mining and I'm finding it for that. And I find this. But if I'm one of the members of the network and I try to go back in history and change that data, I'm going to break my blockchain, and I'm going to be sort of like how I'm immediately identified with my signature. All of them are tied together. It's called a Merkle tree. So you take like a little bit of the root color and you take all of these, a little bit of the hashes from the previous ones. And so that's how it would be identified. That's how they're all tied together in a block. If you are trying to be part of a blockchain network and you don't have a valid network, if you don't have valid blocks, it's going to be immediately identified and you're not going to be able to add a new block to the blockchain. So when you're talking about mining for Bitcoin specifically, proof of work, this is the work that they're doing. Everyone's looking for that nonce so that they can add a new block to the blockchain so that they can get the financial reward. The more valuable that the reward is, the more people that are going to be vying for that. Another point I want to make here too is if you go to Etherscan here, you can see these latest blocks. This is on Ethereum here. And you can see the miner, pool in 2, Ethermine, pool in 3, pool in 2, Ethermine. So I'm just sort of bringing up if this is truly, decentralized as the way they want it to be, there wouldn't be maybe 3 or 4 miners that are being able to mine all the blocks. So for me personally, knowing a lot about blockchain, I do think it's a very cool technology, but I do like to call into question sort of like some of these ideas that like, how is it really coming into effect? If, for instance, only the people that have pooled their resources, or it's not very decentralized to be able to find this nonce, is it only going to be a couple of players that are actually finding the blocks? And would, I'm airing the question, would they be able to collude and possibly change transactions? It's not so possible, but it's more possible when that is becoming more centralized. All right, so that's a lot about transactions and going into mining. Okay, so this is more about mining. The other thing I just wanted to mention about transactions, it's a little bit hard to picture, but so sometimes when you have this transaction, it's going to go, and it's a little bit more complicated than this, but it's going to go in something called a mempool. So what happens is initially is if you want to send someone money from your wallet, it's going to be going through this gateway before it's reaching. But anyway, it's going to say like, okay, this is going to be a valid transaction that we can add to the blockchain. This is going to be a valid transaction. So this is like lists of these transactions. And so until a node finds that nonce, or until you get out of that mempool, your transaction won't be complete and won't be on chain until it's actually added to a block. So it goes into a pool until it's added to a block. And the other thing I like to say is that, so for Bitcoin too, when you're running that software, there's limitations on how fast these hashes or these nonce can be found. So there's a self-correcting difficulty level. If people all drop out of trying to find Bitcoin, the difficulty level also drops. The software self-adjusts. So if they want around 2,000 blocks per 2 weeks or something like that. And so if there's too many being found, the difficulty level goes up. If there's too few being found, the difficulty level goes down. So there's a real question of scalability for Bitcoin. There's Bitcoin Cash. So how is the process to pass from a transaction in the mempool to a block in the blockchain. So that's like, there's like a multi-step process, but essentially it's validated. And then when it's like sort of like in a line, and so some nodes can take that on, and if it'll eventually get put into, it's a little bit difficult because there's like a sort of like an 8-step process that I kind of want to get through the rest of my stuff for. And I just like don't even have it totally memorized offhand, but I could send you a link after this if you want to send me an email or a LinkedIn message. How are the blocks distributed between the different nodes? So for a full node, everyone that is on the blockchain has all of the blocks. So they're not distributed. And well, I defined what a nonce is. A nonce is just a number found only once. And it's going to be a number that satisfies the, it's sort of like a difficulty. It's when you're saying you're like solving a problem, you have to solve these problems. So then you have to find a number that will satisfy, that is like just below the difficulty level, that'll satisfy the hash. And that it will make it so that, you know, that you can add this block to the blockchain. Okay, so let's see, what is my next item that I'm going over? Am I going over time here or no? I guess not. Okay, so smart contracts. So as I mentioned before, Bitcoin is the original blockchain, but it is limited. So some of the developers of Bitcoin got this idea that this technology, this sharing of transactions, this immutability, it doesn't have to be limited to just having transactions. This is where smart contracts came into play. So this is Ethereum. So this Ethereum is a new database also, but it has new capabilities. So what are those capabilities? It can execute bytecode that is the smart contract that you deployed on the blockchain. So there's like an Ethereum virtual machine. So let's go back to what this network looks like. So here, this is my blockchain network, but now I am going to have, in sort of like simplistic terms, I'm going to have these virtual machines here too that can now execute bytecode. What am I doing here? SVM, EVM. These are all, they're all running, and they're also all in synchrony too. So these are going to all know about contracts, and they're going to all be able to execute them based on transactions. So let me see what my topic was here. So that's what a smart contract is. So for smart contract, you can, there's different standards now. So for instance, like if you want to create an NFT, there's different standards of methods that you have to implement and things that you have to take care of. And this is sort of like learning from past errors or past mistakes. And so these smart contracts are now being able to be deployed onto, not onto, and Bitcoin is totally separate, but onto a blockchain that can run bytecode. So a smart contract, when you are having those that's another transaction. Like anytime that's executed, that's going to cost you money, because it's going to execute that, because it's going to have to be, you're going to have to pay your miners to find the other block. There has to be some sort of incentive. There's other forms that are more energy efficient, like proof of stake. There's even a private blockchain network, for instance. If you want to have a blockchain within your corporation, you're going to have nodes wherever you say in any given places. If you're going to have an AWS instance, for instance, and you're going to say like, we're private and we're going to just know that we're all trusted. So anytime any one of us wants to add a new blockchain, we're just going to say, okay, and we're all going to keep in synchrony like that. So that's where smart contracts come into play. So someone asked, what is an NFT? And so that could be a lot of things. And it's, of course, stands for non-fungible token. But really what it is it's like an entry in one of these blocks that is made public. So for instance, if I own an NFT and I'm on the Ethereum blockchain, most likely it will say that this wallet owns this NFT. And the other thing about an NFT is that usually that actual art, for instance, if it's art, it's not even held on the blockchain. Often it is a link to an image. And so the other question I like to raise about that is, how often are there broken links? So what happens if your link breaks? Where is your link held? There's another really interesting blockchain, and it's called Arweave, ARWEAVE. And what they're trying to do is have that resiliency for data, sort of being like a blockchain for Wikipedia. Okay, so yeah, so smart contracts, you can have like, you can be really creative with them and inventive with them, but they're basically enabling transactions to happen between wallets and software to happen. So when I logged into even like CryptoKitties, those are smart contracts that are, you know, I don't play that game, but it's basically like creating a new CryptoKitty and then displaying that you own it or something like that. But it could be, you could have like a lot of games or ownership changing. Yeah, there's a lot of different, it's almost as like whatever you can think of, like you'd have a public contract to be, you could use in a smart contract. Okay, so what are some of the risks? So two off the top of my head, and I'm running a little bit low on time. I just want to go back to this Etherscan here. And so, yeah, you see Etherscan here. You could see this is my public wallet. But you could also see a lot of people's wallets here. So this Ether value is $11,000. This person has 7.47. I don't know if you can see this or if it's too small. Ether. There's the transaction hash. That's the person that it's from. So this is like public information. So, I mean, what if it was quite a lot of money, which it can be? I mean, this could open you to hacking. And so it doesn't necessarily have to be hacking your wallet, but it could be hacking your computer. If there's a lot of money on the line and these transactions are public, that's kind of a risk. And so there's been so many people or scams that have lost money like this. It could be a lot of money, and like a lot of the information is public. So is Bitcoin one blockchain or multiple blockchains? So Bitcoin is one blockchain. So there's Bitcoin Cash, which is like a forking of that because it tried to change it. But really, Bitcoin blockchain. So Bitcoin is a cryptocurrency where all the transactions are recorded publicly on the Bitcoin blockchain. Okay. So it's really one blockchain. And so an NFT, you can have an NFT on multiple blockchains. You can sell the same NFT, but really what an NFT was, I think, of like an entry in that blockchain or a smart contract that has been executed on a blockchain. So let's see, I have an example of another risk if I can find it. There was a company that lost like $80 million or maybe more than that just by executing the wrong contract. So let me see if I can find that. So for instance, if you have an error, if you have a bug and you execute that and you're running a company and then people are gaining money by accident. And then it takes, a couple more days for that contract to get re-executed because of the transactions that they're immutable and you don't really know who anyone is, then you're going to lose all that money and there's not really anything you could do. So you think about a production error, maybe you'll have some way to go back on it, but the blockchain is immutable, and so you can't really take something back right away. Let me find the article. No, I can't find it right now. That's fine, but we can find a bunch of example. It could be Qubit Finance. But anyway, let's move forward. My point is really that if you execute a contract and then there's an error in it, there's something wrong with your transaction, you can't take it back. You can have your own local instance, you can have development instance, you can have test nets, but if you send something out, you can't really take it back. So that's some of the risks. The transactions being public, someone trying to hack you, that could always be a problem. Not necessarily steal your wallet just by guessing your passwords, but if you have quite a lot of money, there will be people that are watching that, and that you could be a risk. So do I think Ethereum 2 will get off the ground and use proof of stake instead of proof of work? So I do think that it is getting off the ground. I thought there's like some deployment date, I'm not even sure. And so proof of stake, just to mention briefly what that is, it's basically if you want to be a miner, you're basically putting up some collateral and you're saying, I am going to put this as collateral so that you know that I am a not like a malevolent operator, and you can check out my blockchain. And then there's a lottery, and so via lottery, the people that put up the collateral, they could be the person that create or add that block to the blockchain. Okay. And so development. I just wanted to mention briefly too. So you don't have to really spend any money if you want to start developing or creating some contracts you can have on your local computer and environment to test out executing your contract. You could also use a bunch of the test networks. If you want to say, let me show you my wallet again. About that. I want to I'll load my wallet again. So if I go to my Rinkeby test network here, you could see that if I want to send out some, so I have like 18.75 Ethereum on the Rinkeby test network. So you can request that money. It's really fake money. And so I can execute contracts as much as I want. I can send money to different accounts on the test networks, but that's one way that you can get your development off the ground. You can also use this here. It's called the Truffle Suite, and there's great documentation here. If you want to just start executing some contracts, there's some sample contracts there that you can download. It gives you really great examples of just sort of like frameworks and sample code if you want to just like execute some contracts. I definitely recommend that. And the last thing I wanted to mention, because I'm running out of time, is I wanted to just mention in case you don't know the difference. So there's a lot of talk about Coinbase and there's other exchanges. But for instance, if in a cryptocurrency exchange, you don't need a wallet to own cryptocurrency. Basically, you could go onto an exchange and like you were going to buy foreign money, I could buy foreign money. I could buy different cryptocurrencies. And I don't even necessarily need a wallet. And those values can go up and down, just as if I buy foreign currency. And then I can also sell that money. You don't have to link it to a wallet, although you can. And So people own cryptocurrency oftentimes without even ever having to spend it, just by buying and selling on something like Coinbase. For smart contracts, I would recommend Solidity, and it's like pretty readable. I find it pretty much like a very straightforward OOP language. It's like, yeah, I would recommend, or if you're familiar with Go, you could use Python too, but any one of those languages, Go or Python or Solidity, but I'm most familiar with Solidity. So you can use JavaScript or TypeScript to actually execute your code and to compile it, but you can't really use it to write the smart contracts to have that run on the EVMs. But you know what? There's like so much information changing all the time. I just don't even want to be firm about that. But okay, so yes, so that's my talk. So thank you so much for bearing with me with my technical challenges here. But yeah, it's just because I didn't have like regular slides. So
thank you so much for this presentation. I think that so many people have mentioned in the chat how much they have learned. Do you want to share where people can get in touch with you easiest if they want to follow up with more questions, since we are out of time?
Oh, sure. So if you want to get in touch with me, I really am not that popular. You can just like email me directly. I'm on Twitter, but I don't have anyone like following me, and I'm on it all the time though. On LinkedIn, I'm there too. I don't even know if I'm Ann or Ann Malavet on LinkedIn. But that's it. Yeah. So yeah, definitely just email me. I check my email all the time.
Well, again, thank you so much for all of our attendees. Thank you for joining this session.